In our HackerRank problem for a Halloween sale, we want to buy video games from the famous online video store. Usually all the games are sold at price P in dollars. However, they're going to have a seasonal sale next month where we can get these games at a cheap price. So specifically, the first game will be P dollars, and every game after that will be D dollars less than the previous one. It's going to continue until the cost becomes less than or equal to M dollars, which is going to be like the base price of every game. So we're asked how many games can we buy during our Halloween sale? We're given an example here. We have our function description as well as what each of these variables mean. This is important. You should probably keep note of each of these. P is the price, D is discount, M is minimum cost, and S is our starting budget. So these are our constraints as well. Each of these has to be less than 100, D is less than 100, and S has to be between 1 and 10 to the fourth. We have sample input and output, two of these actually, so you can have two test cases. Now let's look at our code right here. So this is going to be the class that tests this. It's going to run and test it. So we're going to focus on the class that's result, and specifically in the method public static int how many games. We have our P, D, M, and S. So let's code in here. How are we going to want to do this? Well, think about it like this. S is the starting budget. So we're going to walk into the store with this amount of money. Every time we pick up a game, which would be like P, the price of the first game, we are going to want to take this price and subtract it from our budget. And then we can take whatever is the D value and subtract that from P. Because, you know, every single time it goes down more and more and more, the more games you buy, until we get to this base price. So the price that we're subtracting from here is going to be either P or M. M is the minimum value. Once P is less than M, we have to just pay M. So how are we going to do this? Well, if we want to run this all the way down, we don't want to run it necessarily all the way down to 0, just until we can't afford this base price anymore. Let's do a while loop for that. Remember, our S is going to be decreasing every time, so we're going to do S is less than or equal to. Remember, we're going to be decreasing P every single time. This is the price of the game, so we're going to be manipulating this variable a lot. So as long as S is greater than or equal to P, we are going to be inside of our while loop. Now, inside of our while loop is where we are going to do this math. First, we want to pick up a game. So we're going to have S, which is our total price right now, minus equals to P. So that's basically saying if we start out with 20, so if we know our test cases, I'll just put them in right here. Let's do the first test case where we have P as 20, D as 3, 6 as our M, and our budget is 80. So when we start this off, we have an integer budget of 80. So we're going to take minus P from that. So we subtract 20 off of this S because now we have 20 less dollars. Now every time we do this, remember we want to return the count of how many games we're buying. So let's make a variable up here called count. Int count is equal to 0. We're going to eventually want to just return count. Now every time we run through this, I'm going to think that we would need to increment our count, right? Because that's just us picking up a game. Every single time we pick up a game doing this, we have to do our count because that's an increase in how many games we have. What happens, we're going to continuously run this, right? We're going to decrement our total value right here. And what happens when we get to this M, this base price? Because eventually we are going to run out of money and we don't want to go below this base price. So let's actually change this P, because if you've noticed so far, we haven't used D at all either. Remember, D is every single time this P runs, we decrement the value of how much we have to pay for the next thing. So to do this, what I'm going to do is say P, after we do this operation right here, is going to be equal to a math.max. And inside of here, I'm going to pass our M, because we want to see which is greater, the M value or our P minus D. So P minus D like this. So the first time, this is going to be 20, right? And then when we come down here, we are going to say, well, what's the maximum value? Either M, which is 6, or P minus D, so 20 minus 3, so or 17, which is greater? Well, 17. So 17 is going to go here, and it's going to go on and so forth until, I'm not sure exactly when it's going to stop, but like let's say P minus D eventually ends up to be 5. Well, 6 is greater than 5, so we're going to start wanting to use 6 as this P value. And that's how we would go inside of here. Hopefully that makes sense. If you have any questions, you can leave them in the comments below. Let's try submitting our code. There's a lot of tests this needs to pass, so if you do it, try to make sure you run the test cases, or there's a test case before you actually submit it. I do have a compilation error, so let's go back and look at this. Oh, and it's probably because I didn't have a semicolon after this. But like I was saying, if you run your code first, you can check against the 2 tests just to make sure it's working at a bare minimum before you try to run it against 50 different tests. So we can see it's testing all these cases right now. It's passed these ones, and it passed all the cases. So that's how, again, we would look at this problem. Just a quick review, we take these variables as parameter in our method. We have this count, which we're going to return. This count's going to increment every time we pick up a game. Now our sum of money is going to decrement every time we pick up a game, because every time we pick up a game, it's essentially buying it, so we are losing our money in exchange for this count. And that's where this comes in, where we take away how much of the cost of the game was, which is P, from our total sum. And we know we can't go lower than M, so that's where this math.max comes in.